Now say a dual nature of radiation and matter. This is the new chapter here. In this chapter, we will be studying about the photoelectric effect and de Broglie's waves. That is means de Broglie wavelength. Now see your first topic is in this one, that is called work function. Now see, what is the work function? In this case, we have to study actually about the energy required to make the electron free. As we know it, if you have taken any atom, there the positive charge is at the center, that is the protons, electrons are around this nucleus part. But these electrons which are over here, they are not free, because as the electrons try to come out of this atom will become positive ion and electron is negative ion. So, this positive ion will pull the electron towards it. Because of that, electrons cannot be free. So, electrons cannot be free, it means conductivity cannot be increased. We cannot get the conduction of current. But to make these electrons free, we need certain amount of energy. So, the minimum energy required to make the electron free from the atom is known as work function. Work function is actually given by the symbol here phi naught. This can be written here h nu naught, where h is here Planck's constant and nu naught is known as here threshold frequency. Work function is measured in electron volt, that is written EV, and 1 electron volt is equal to 1.6 into 10 raised to power minus 19 joule. So, work function is actually measured in electron volt. Now, work function of the any metal depends on the two factors. One is the nature of the metal, another one is also the nature of the surface of the metal. So, these are the affecting factors of the work function. You know, we can emit the electron by the following ways. First one, we can take here, that is called thermionic emission. In thermionic emission, actually metal plates are provided heat. So, by enough heating, we can make the electrons free from the metal surface. Second one is known as field emission. In field emission, by applying very strong electric field, we can separate the charges here, we can separate the electrons. So, by using this field, electric field, we can also make the electrons free, that is called field emission. Third one is here known as, that is called photoelectric emission. In photoelectric emission, you know what happened, radiations of the suitable frequencies made to fall on the metal surface. Because of that frequency of the radiation, we get the energy, that is the phi naught is equal to h nu naught. So, by making fall of the radiations of the suitable frequency, we can emit the electrons. That type of the emission is known as here photoelectric emission.